Welcome back to the final installment of the Unit 5 lessons. This is lesson 5.6. And 5.6 reads like this. I can determine the molecular formula of a compound given the mass or percent composition and molar mass. So if you look at the skill sheet, this is the final skill of the unit. And what I highly recommend is that you're comfortable with skill 5.4 in order to understand skill 5.6. So 5.6 is just like 5.4 to an extent, and then there's just an extra little step at the end that we have to add. So once again, if you're not comfortable with 5.4, please watch this video first, and then head on over to 5.6. Otherwise, if you feel good, just keep watching, and we'll toggle back and talk about what we got to do today. So this here to the left side is a graphic from video 5.4. Remember, we know how to solve for a empirical formula, okay? And what does empirical kind of mean? It means most reduced formula. And what are reduced? These things called subscripts. A molecular formula is, we could say, the true total of elements in a compound. So in a previous video, we figured out the empirical formulas, okay? Today we'll repeat those same steps, just that we take it one step further at the end, and we'll solve for a molecular formula. Okay, so here are going to be the steps that we take today. So step number 1, we want to gather molar masses of the elements in the compound. To use proportions to convert from mass to moles. Number 3, again, these should all be familiar. Write a ratio. And here's going to be the last rule that really kind of switches it up on us. Find molecular formula by using a total molar mass. So again, these 3 steps we've done in video 5.4. There's a final step here to take care of at the end. This would be a good time to pause the video and to write down these steps for yourself. And if you've done that, what you can do now is roll down to the example problem. So here's how an example problem will read. So it reads just like an empirical formula problem, except they're going to add one piece of information, and I'll show that here in a second. So a compound is composed of 7.20 grams of carbon, 1.20 grams of hydrogen, and 9.60 grams of oxygen. So we're going to highlight these as masses that we need to convert to moles, okay? But here's where we get one final piece of information that lets us perform an additional step. The molar mass of the compound is 180 grams per mole. So when we read this sentence, that will allow us to compute a molecular mass, okay? And it says determine the empirical and molecular formulas. We're going to have to figure this out first and then take care of the molecular formula next. All right, so what do we have to do? Well, basically, again, just as a previous problem, we're going to list out all the elements kind of horizontally. We're going to find the molar mass of 1 mole, make our proportions, and then come up with a ratio as you've previously seen. So let's go ahead, let's write some stuff down. So we have 7.20 grams of carbon, 1.20 grams of hydrogen, and 9.60 grams of oxygen. Okay, let's set up proportions for each of these. And remember, we want to figure out how much a mole of each of these weighs. So we will need our periodic table now to figure out a mole of carbon. So carbon's mass here is 12.011 grams. Let's go ahead, let's write that in. Perfect. Okay, how about hydrogen? 1.008. And oxygen, 15.999. So let's go ahead, let's put that in. Now we can do is take the given piece of information and tackle each one of these proportions to come up with an algebraic expression and then solve for x for each. So you can see this might be kind of a lengthy process, and these problems will definitely take you a moment to complete. So remember, we want units the same at the top. We're solving for moles. And our given piece of information is the mass of carbon. Cross multiply. We get x times 12.11 grams is now equal to, mistake here. This should be 7.2 grams. That is our given, okay? So then we get 1 times 7.2 grams. And what I now need to do is take care of the multiplication on the right side. So 1 times 7.2 is just 7.2. Remember, 12 is multiplied by x. So what I have to do to get rid of it is divide by 12.011. And whatever I do to one side, you have to do that to the other side. And now let's come up with the decimal. So 7.2 divided by 12.011 gives us 0.6 moles of carbon. Okay, so now for the sake of time, what I will do is I will now list in all of these missing pieces of the proportions and then solve them so that we can kind of cut to the chase a little bit quicker. So what I'm about to do is the same thing I've just done here at the top, just with different numbers for the hydrogen and the oxygen that remain. So at this point, when you can pause the video, try to work this on your own. When you unpause it, you should see all the answers, and we will kind of move ahead. All right, welcome back. Our two remaining answers turned out to be 1.2 moles of hydrogen and 0.6 moles of oxygen. So now, since I have my moles that I've converted to, remember the last step that you need to take care of is come up with ratios, okay, of each of these numbers. So what I will have to do is come up with a couple ratios for each of these. So 0.6 divided by 1.2 turns out to be 0.5. And if you turn this decimal into a fraction, it ends up being 1 divided by 2. So what this says is I have 1 carbon to every 2 hydrogens. Okay, how about this? Let's do the next one. 1.2 divided by 0.6, okay? If you put that in your calculator, what you do get is the number of 2. And remember, whenever you get a whole number, divide that by 1. And what now this tells me is that there are 2 hydrogens for every 1 oxygen. And what I want you to notice is that the numbers for oxygen and carbon are the same. So there is 2 hydrogens in comparison to each of those. So here is the empirical formula in no particular order. So remember, there's 1 carbon for every 1 oxygen. There is 1 oxygen for every 2 hydrogens. And we also discovered that there is 1 carbon for every 2 hydrogens. So let's go ahead, let's write that. So carbon, there's 1, 2 hydrogens, and then here is 1 oxygen at the back. And there we go, that is our empirical formula. So here's where our last step kicks in. What we have to do now is take this empirical formula and we want to find a molar mass. So I know the molar masses of carbon, hydrogen, and oxygen from the proportions. So let's go ahead and let's write those in really fast. So carbon was 12.011 grams. Hydrogen is 1.008 grams. Remember, there's 2 of them, so we'll have to multiply that out by 2. And then remember, oxygen was 15.999, and according to this formula, there's only 1 of them. What I'm going to do is multiply out the hydrogens and then add all of this together. So 12.011 plus 2 times 0.1008 plus 15.999. What that comes out to be is 30.026 grams per mole. The last step is to divide the molar mass of the empirical formula by the total molar mass. So what was the total once more? Remember, we've circled it quite a few times, 180 grams per mole. Okay, they clearly tell you it's the total. So let's now go ahead and take 180 divided by 30.026 grams per mole. And what we're going to do is round this to the nearest whole number. So I do 180 divided by 30.026. What I do get is 5.9. But the nearest whole number is 6. So this is my multiplier. And here's what this 6 means. I will take this 6 and I will multiply the subscripts, okay? So these are the subscripts here of the empirical formula. So carbon has a 1, we don't write it. Hydrogen 2, and then oxygen 1, and then it's a done deal. So let's go ahead, let's do that. So 6 times CH2O will give us C6H12O6, and that is your final answer. That is the molecular formula.